reviewing the history of mathematics, something occurred to me here, and that is that the Hilbert program was doomed centuries ago. So here we have a brief overview of the history of mathematics descending from the Greek tradition. So the Pythagoreans claimed that counting numbers were the only values that existed. So to them, fractions are always ratios between two counting numbers. But then somebody in the Pythagorean group discovered irrational values, and they called them alogos, or inexpressible. And it is sort of the similar period, Zeno of Elea proposes his paradoxes. So these would be, the Achilles and the tortoise and the arrow and all this whatever. Atalanta running, all that shit. And he proposed them to illustrate that discrete and continuous values are distinct from each other, right? And this fucks with the Pythagoreans, right? So how are you able to just continuously divide in half and never reach an endpoint? Right? The Pythagoreans wanted there to be an endpoint, so that's kind of a problem. Anyway, so after all of this nonsense, there is a brief period where shit actually works. Not everything works, but a lot of things. Some things that don't work now worked. So you have Eudoxus of Cnidus, some shit like that, formalized a distinction between number and magnitude. You might recognize this as basically the position that I take. And I didn't get it from him. I came up with it on my own, and I actually just learned about this shit today. Like, I never heard of this guy before. So, continuous and irrational values are magnitudes, not numbers. And what you can do is you can take some such measured magnitude and use it as the base of a number system, if you so wish. So you can have different number systems that are incommensurable with each other, right? You can have one where the unit is the square root of 2, and you can have one where the unit is 1. And as far as, rational and irrational numbers go, those are incommensurable. You can never get them to quite talk with each other correctly. Anyway, so as a result of this, geometry became the sole method for handling incommensurable ratios. So, yeah. Numerical approaches like algebra were rather completely abandoned. And it wouldn't be called that because Arabic didn't exist yet. This term hadn't been invented yet. Algebra. But then it gets broken again because guess what gets invented? Muslim mathematicians develop algebra to allow irrational values to be treated similar to numbers. Now, in a certain point of view, this is really, really fucking nice. But they merged number and magnitude into the real numbers. This is where this is coming from. And this is about the time that Beowulf is being written. Like, this is a long-ass fucking time ago. The English language didn't exist yet. It's that long ago. Okay? I mean, if you want to claim that the language of Beowulf is English, you're retarded, but whatever. No, it's not. Right. So this decision was made before something like Geoffrey Chaucer, which is recognizably English for the most part. And at this point, as far as I can tell, surds are the only irrationals which are considered to exist. So the surds are roots of things. So square root, cube root, fourth root, whatever. Right. And then a little bit later on, 1600s, imaginary numbers are invented in Europe. This gives us complex numbers. And roughly simultaneously, I think maybe a little bit before this, it's early in the 1600s, logarithms are invented. I think it was by Napier. And E is discovered. pretty much, yeah, E is kind of the base for the first logarithms that were discovered. So the precedent of merging magnitudes and numbers meant that these new objects would be considered numbers, right? So your imaginaries are going to be considered numbers, and your logarithms are going to be considered numbers. Fast forward a few centuries, and we get, so like the late 19th century, the late 1800s. Logicism assumes that mathematics should be reducible to formal logic, and about 40-50 years after this kicked off, Kurt Gödel demonstrated that this is fucking impossible. So here's some basic ass questions that I have. If Peano's axioms could only derive counting numbers, how in the fuck was it expected that they could also derive irrational numbers? Like, this remains a basic problem today. How do you express pi? How do you express E? If they're numbers. Like, we never resolved this problem that irrational values are inexpressible. We never resolved that. Right? The trick that algebra uses is was just like, yeah, we'll give it a name. You know, this is pi. This is whatever. This is E. This is. We'll just name it something. We'll give it a name, and then we can just treat it as sort of its own unit. That's fine. That's the trick that algebra used, right? It didn't actually solve this problem. Okay, so if Peano's axioms are supposed to derive all the numbers, and you think that irrationals are numbers, what the fuck? How? How does that work? Okay, and another one, if imaginary numbers have the same magnitude scale as real numbers, isn't the magnitude scale really the number component, right? So you can have positive 7 and 7i, negative 7, negative 7i. The number component in all of those is just 7. 7i isn't a number, it's a vector. Positive 7 isn't a number, it's a vector. Negative 7 isn't a number, it's a vector. Negative 7i isn't a number, it's a vector. Why are you calling these numbers? So isn't it worth preserving the contrast between counting numbers and non-numeric measurable quantities for the sake of clarity in argument, right? So non-numeric measurable magnitudes being things like the distance between my house and the White House. Or if you draw a square, the distance between two opposite corners. Or the distance between any two corners. Right? You can define either of those distances to be 1. But then relative to that, the other one will be irrational. Right? So if you have the distance between two adjacent corners being 1, then the diagonal will be irrational. And if you have the diagonal being 1, then the distance between adjacent corners will be irrational. One of them you can't actually commensurate with the other. Right? If you can express one, you cannot express the other. Okay? So another one is that it's been noticed that the geometric approach, which Muslim mathematicians rejected, is not subject to incompleteness. This is what I mean up here where I said this is a brief period where shit actually works. Because you don't have incompleteness occurring here. It was this which introduced the problems that brought about incompleteness. For a while, I thought it was logicism itself. No, I'm pretty sure it goes back further than that. So, yeah, if the geometric approach is not subject to incompleteness, why hasn't this been acted upon? Why are we still using as mainstream mathematics basically logicism? Why are we still using this when we know that it doesn't work, and We know that there's a system that works better. What the fuck are we doing? And then the final question, given all of that, what part of this is logical? What part of this? What part of this is fucking logical, guys? Are you serious? What part of this makes sense? Okay? Like, at this point, this is early on. Making a misstep here, forgivable. It's forgivable. But by the time you get here, by the time you have Gödel demonstrating incompleteness, and you have people who are capable of looking at that and being like, oh, fuck balls. And, notably, incompleteness was known and pretty much expected before Gödel demonstrated it, right? Before it was proven. So this idea that he came out of nowhere with this is bullshit, right? Because he published this in, 31, I think? And you have the little Polish guy. I can't think of his name. He was like an 18-year-old kid, okay, who's like comes up with a modified version of piano arithmetic, right? That doesn't have multiplication, and it's specifically the presence of multiplication that Gödel showed causes incompleteness. So this 18-year-old kid who was definitely being like groomed for this position by figures like, I think it was Lukashevitz. I think it was him. Yeah, it wasn't the 18-year-old kid that figured this out, right? It's the broader community of like established people within the Hilbert program. They knew this was a problem years before Gödel published his shit, right? What it was is that Gödel definitely made it so that, yep, this doesn't actually work. There's no fucking way this works. He published the formal proof of it. But it was known. It was expected beforehand. So, like, why are we using this? What the fuck? What part of this is logical when we know this doesn't work? You cannot reduce mathematics to formal logic. Because when you try to, you get incompleteness. And one of the core problems is that you're calling everything a number. Ultimately, that's where part of the problem comes from. You're trying to call everything a number. And you're not recognizing other issues like mathematics fundamentally operates over units, not numbers. Or at least more fundamentally operates over units. And this, when you allow that, now you're able to handle the difference between magnitudes and numbers just fine, right? Because you have a number of units, but the magnitude of your unit can be fucking anything, right? So now we can have two unit systems where one of the units is square root of 2 of the other unit. That's not a problem. And we can have 4 of one unit, and we can have 7 of the other unit, and that's totally fine. But relative to each other, they're now irrational numbers. Those distances that those two systems are measuring off, one of them is going to be an integer number, and the other one's going to be an irrational number. What's wrong with that? There's nothing wrong with that. But what you're trying to do is you're trying to make it all one system. One single number system. And that's where it breaks. And it goes back to algebra. The development of algebra where the geometric Greek approach was basically tossed out. And like, no, we can do this differently. And we can do this better. That idea. And at the point that it was made, that, like I mentioned, it's not necessary. It's not foreseeable at that point why that would be a mistake. But by the time you get to Gödel, a little bit of retrospection makes it obvious that's where things really started to fall apart. Right? Because up to here, we don't have incompleteness. Where we get incompleteness is here. Right here. Not here. Here. Also, we have a problem with incompleteness here. Right? Which means that the Greeks, in developing this geometry-based system, they resolved that problem without necessarily even understanding, at least not in modern terms, what that problem was. They were fixing other problems. I don't know. I found this interesting. As always, you're free to disagree with my interpretation of things here, but that's pretty much what I'm seeing. So, yeah.